Hi, welcome to a Super Space Super Short, and I wanted to talk about the idea of tiny black holes. And I will begin with a short look under fair use policy, considering this is a critique, of just a little portion of this video from PBS Spacetime saying, what if tiny black holes are everywhere?
This would be when the black hole's mass is around 20 micrograms, what we call the Planck mass. It doesn't sound like much, but that's around 2 billion joules of energy. Such a black hole would have an event horizon around 10 to the power of minus 35 meters, the Planck length. This is the size scale where general relativity and quantum mechanics comes into hopeless conflict.
So he is talking about, and I won't talk about the process because he goes over that earlier, but if a black hole through a process evaporates to this tiny size of the Planck length, then essentially it is a quantum black hole. And some people have proposed that this is what dark matter is, but mathematically speaking, this could be a quantum particle. And so when in superspace theory I talk about quantum particles as holes in fields rather than excitations, the math we are talking about here could be describing quantum holes, which are quantum particles.
And is sometimes thought of as the smallest possible chunk of space. So, might Planck-sized black hole relics, or Planck relics, actually exist? Well, let me start by saying that we know for sure that general relativity doesn't work on Planck scales.
And so this simplified, the reason general relativity doesn't work in the quantum scale of things is that when we try to combine the math of general relativity with quantum mechanics, what mathematicians consider breaks down because it gives the answer of infinity, which is actually the real answer, which is talking about this fourth spatial direction, which is leading in a potentially infinite direction in the fourth dimension, as superspace theory shows. So I won't keep playing the video and just say that even without being a mathematician, I can see how a lot of the math that's being utilized is describing this curvature into a fourth spatial direction of the fourth dimension, which is what we think of as the very small, but which the math does not actually state is smaller, but is a fundamentally different direction, which leads infinitely out of our own three-dimensional universe. Thank you for watching.